Okay, Jock, this is Mr. Burrows. Today we're going to try something a little bit different. I didn't really like the way my videos were being sent. I know you couldn't see the screen. So today we're going to go through the note packet as I'm filling it out. If you could take notes, that would be great. I guess we'll see how this goes. So if we go to the top of our do now here, the first one says, write a situation from real life in which X, something you choose, is less than or equal to 20. Then graph the situation on this number line. So, if you want to pause the video and take, a minute or two and see if you can come up with your own situation and then graph it on the number line, that would be great. Alright, hopefully you've push play again, and you can compare yours to mine. So I said something that is less than or equal to 20. So I said in a lottery, I can win less than or equal to $20. Not a great lottery, but the situation still works. So X is the amount of money I can win, and we would write that X is less than or equal to 20. So again, we read this symbol here. This is our less than, and then with the line on the bottom, it makes it less than or equal to. So now looking down at my number line, I want to see how can I plot this in this situation on here. So I'm going to go to 20, and I'm going to make a closed circle because 20 is included, and then I'm going to shade this direction. So this is how I write X is less than or equal to 20 on my number line. This is how I write it as an inequality, and this, in a lottery, I can win less than or equal to $20, is my real-world situation. So if we look down at number 2, it says, group the following words and symbols into 2 groups. Circle all of the items in your first group and draw a box around the items in our second group. So I have 10 items here, 4 words, 6 symbols, and I want to put them into 2 groups. So one thing we're trying to get at here is we want you to connect, this symbol right here that we use number 1 with this dotted line. So we call those the inclusive symbols. So this is, my closed circle with my less than or equal to. So my solid line, my greater than or equal to, my less than or equal to symbol, my greater than or equal to symbol, and my closed circle are all going to be my first group. In my second group, which I'm going to make squares around, my dotted line, greater than, my open circle, my greater than inequality, and my less than inequality. So these are my 2 groups. Again, dotted line, greater than, open circle, and then these 2 inequalities that don't have the line under them. And then my other group is my solid line, my greater than or equal to, my 2 inequalities that say less than or equal to, greater than or equal to, and my closed circle. I'm not sure how much you got from those last 2 lessons because I know you couldn't see the board. Hopefully we can start to see the connections between these symbols. If not, we can do a review and put all the pieces together. So next we're going to go to our next page. And the top question. So this is our launch. It says, Kevin Durant will make $100,000 for every game that Golden State wins during the regular season, and $1 million for every game they win in the postseason. If the Warriors win 70 games in this season, how many postseason games do they need to win in order for Kevin Durant to make more than $15 million? So, he is getting paid for every win. So for every win that they have during the regular season, he gets $100,000. Every win during the postseason, he gets $1 million. I know that they win 70 regular season games, and I want to know how many postseason games do they need to win for Kevin Durant to make more than $15 million. So pause this video and take, however long you need. See if you can figure out how many postseason games does he need to win to make more than $15 million. Alright, well, when I saw this question, my first step was to say, I know he won 70 regular season games. Every regular season win, he gets $100,000. And for every postseason win, he gets $1 million. So, if he wins 70 regular season games, and we multiply that by $100,000, and I use this number because this is the amount he wins for every regular season game he wins, this equals $7 million. So, just from the regular season, he is going to make $7 million. Now, I don't know how many postseason games they're going to win. That's what I'm interested in. But I know that for every postseason win, he gets $1 million. And so we're looking for that total. And then I also know that he wants to make more than $15 million. So that means my total during the regular season, which is $7 million, plus my total during the postseason is going to be greater than $15 million. So I'm looking for my quantity here, we'll call it Y, that makes this whole thing true, that makes 7 million plus Y is greater than 15 million. So I need to know what Y is. So to find Y, I can subtract 7 million from both sides and get Y is greater than $8 million. So from here I know that my total for money has to be $8 million, but I need to know how many wins in the postseason is going to give me more than $8 million. So if he wins one game in the postseason, he gets $1 million. If he wins two, he will get $2 million. I'm sure you can see where this is going. So if he wins 8 games, he gets $8 million. But this says he needs more than $8 million. So I know that I can't stop here. So that means he has to win 9 games, which will give him $9 million. So $7 million during the regular season plus $9 million during the postseason will give him more than $15 million total. So going back to the question right here, how many postseason games do they need to win for Kevin Durant to make more than $15 million? They need 9 postseason games won. Cool. So if we look at this part right here, it says write an inequality to represent the number of regular season games X, which in this case was 70, and postseason games Y, that he needs to win in order to make more than $15 million. So the only difference here is that I didn't tell you how many regular season games they won. So we know that the number of games during the regular season is X. The number of games during the games won during the postseason is Y. And he wants to make more than 15 million. Now, what am I missing? I know that he's going to make a certain amount of money for every win they have during the regular season. He's going to make another amount of money for every postseason win. So if I look back up at this problem, I can see that 100,000, which is the money he gets for a regular season win, times the number of regular season wins, plus 1 million times Y, which is the number of postseason wins, will give me the total. And I need this to be greater than $15 million for Kevin Durant to be happy. So, where did these numbers come from? If we look back up here, we had 70, which was the total number of wins during this season, and this is represented by X down here. And then 100,000, which is the amount of money he makes with every regular season win, plus the amount of money he makes for every postseason win times the number of postseason wins. So if we break this down a little bit more, we can see that this right here, this 100,000 times X, is his money in the regular season. And then this right here, this 1 million times Y, is the money he makes during the postseason, which he wants to be greater than 15 million. Alright, there's a challenge problem here on the bottom. We're going to skip it for now. This was just something that if people got ahead, they were welcome to try. You are more than welcome to try this. If you get this problem right and send it back to me, I would be happy to give some extra credit on your exit ticket. So hope that you embrace that challenge. But let's turn it over. We're going to go to the practice section here. So if we look at this first one right here, which text correctly expresses the inequality 5x minus 20 is less than or equal to 4? So pause the video, take 1 minute, and choose between these 4 options. What is this as a sentence? Is it 20 less than 5, an unknown number is less than 4? 20 less than 5 times an unknown is less than or equal to 4? Or 5 multiplied by an unknown is 20 more than 4? Or 5 multiplied by an unknown is 20 more than or equal to 4? These are a little wordy, so take a minute or two and see if you can figure out which text correctly expresses this inequality. So, the correct answer here is B. 20 less than 5 times an unknown is less than or equal to 4. So, let's break that down a little bit. I know that this symbol right here is less than or equal to. So, I could automatically cross out 1. I can automatically cross out C. So I'm left with B or D. So this one says 20 less than 5 times an unknown. So that said 20 less than 5 times an unknown. So 5 times an unknown tells me 5 times some unknown x, but I want 20 less than that, so I need to subtract 20. And it also says is less than or equal to, which is this symbol that we said right here, 4. This is our inequality, so my answer is choice B. So at the bottom here you have 3 word problems. So pause the video, see if you can take 5 or 10 minutes and answer these 3 problems, and then push play and we'll go over them. So let's go over number 2. At a pancake breakfast, children are served 1 pancake and adults are served 5 pancakes. Altogether, they can be served at most 144 pancakes. So that seems important to me. I'm going to underline this. At most 144 pancakes. And that is the total number made by the chef. Select the inequality in standard form, another important one, that describes this situation. Use the given numbers in the following variables, where x is the number of children and y is the number of adults. So this one is a little bit similar to the Kevin Durant problem that we did. So I know that children are served 1 pancake, so I'm going to circle that. And then I'm going to put a box around what else I know. Adults are served 5 pancakes. And then what we underlined the first time, the total is at most 144 pancakes. So at most, that tells me that it can be 140, 141, 142, 143, and it can also be up to 144 pancakes. So the maximum value here, 144, but it could also be any number less. So let's break down this first part of the problem though. So children are served 1 pancake, and x represents the number of children. So if there are x number of children, and they each get 1 pancake, my total pancakes will be x, because it's just the number of children since they each get 1 pancake. Now, my total number of adults is y, and they each get 5 pancakes, so I need to multiply the number of adults by the number of pancakes that each adult get to give me 5y. Now, altogether, they can be served at most 144 pancakes. So this tells me the number of pancakes that the kids get, x, plus the number of pancakes that the adults get, which we said was 5y, can be at most 144 pancakes. At most means it is less than or equal to 144. So x plus 5y less than 144, that is choice C. Alright, let's move on to number 3. Sean is selling pizza and hamburgers to make money and go to San Diego. He sells pizza for $2 and hamburgers for $3. He needs to make at least $500. Write an inequality to represent the number of hamburgers and the number of pizzas that Sean needs to sell in order to go to San Diego. So, hamburgers, I'm going to call those H, are $3, and pizzas, I'm going to call that P, are $2. Sean needs to make at least, so we're going to be greater than or equal to $500. So how is he going to get $500? So if he sells 1 burger, he gets $3, and if he sells 1 pizza, he gets $2. If we add those together, he would make 5. So what our inequality is going to look like, it's going to be the quantity, or the number of burgers, times the price of each burger, plus, put some parentheses around these, the number of pizzas times the price of pizzas, and we want that to be greater than or equal to 500. So we said the number of burgers, or a quantity we called H, times the price of the burger is $3, so H times 3, or 3H, plus the number of pizzas, we said we're going to represent the number of pizzas as P, times the price of pizzas, which is 2, so P times 2 equals 2P. We need that to be greater than or equal to 500. This is my inequality. So Sean needs to sell a certain number of hamburgers and a certain number of pizzas that will give him more, greater than or equal to $500. Alright, we got one more here. Gabby has at most $60 to spend on clothing. She wants to buy jeans and t-shirts. The jeans cost $22 each. The t-shirts cost $8. Write an inequality to represent the number of jeans and t-shirts that Amy... Oh, change this to Gabby can buy. So, Gabby goes to the store. She has $60. She knows that she wants to buy jeans and t-shirts, and jeans cost $22. T-shirts cost $8. So in her purse here, we'll draw a little purse. She has $60. She wants to buy shoes. No, excuse me. Change that. That is jeans. And she wants to buy shirts. The jeans cost $22. The t-shirts cost $8. So how many of each can she buy? No, excuse me, we're just doing write an inequality to represent the number of jeans and t-shirts that she can buy. So I need the number of jeans, which I'm going to call J, times the price of the jeans, which is 22, plus the shirts, we'll call that S, times the price of each shirt, which is $8, to be less than or equal to 60, because 60 is the amount of money that she has. So if she buys one pair of jeans for $22, and let's say she buys one shirt for $8, is this less than or equal to 60? 22 plus 8 less than or equal to 60. This equals 30 less than or equal to 60. So this one works. She can buy one pair of jeans and one t-shirt. But all we want to know is what is the inequality to represent the situation. So that is right here. Where J, the number of jeans, times the price of the jeans, plus S, the number of shirts, times the price of the shirts, is less than or equal to 60. Where 60 was the total money that she had. So, if you could, at this time, do your exit ticket for lesson 27 and send it back to me, that would be great. And then we'll go over some more problems for lesson 28.